Okay, video number 3 on infinite limits. Today we're going to talk about infinite limits as x approaches some number. This is also going to be the definition of a vertical asymptote. So let's look once again at the function f of x equals 1 over x, which of course we know looks like this. Well, let's take a look at two limits. One, the limit as x approaches 0 from below of the function. Two, the limit as x approaches 0 from above of the function. And what we notice is that as x approaches 0 from below, this is going to be negative infinity. And as x approaches 0 from above, this is going to be positive infinity. And from here, we notice that this means that we have a vertical asymptote, which of course we already knew because of algebra 2. And the equation of the vertical asymptote is in fact x equals 0. Gives us the definition. The limit, excuse me, let me say that again. The line x equals a is a vertical asymptote if either, now two possible conditions here, the limit as x goes to a from below of the function equals plus or minus infinity, or the limit as x goes to a from above of the function is equal to plus or minus infinity. So there's a definition for you. That'd be a good one to jot down. And let's take a look at another quick example. We'll go to a new page, and what we've got here is we have example 4. This is page 73, and we're going to look at f of x equals 1 over x squared. We know that the domain of this is x not equal to 0, and if we do a little fiddling on our calculator, we can see that in fact this one looks like this. When we plug in our x's, the y's are always going to be positive. So if we look at the limit as x goes to 0 from below of this function, oops, that was a from below, we notice this is positive infinity. We've qualified for a vertical asymptote, but just for fun, let's look at the limit as x goes to 0 from above of the function. And that's also positive infinity. So boom, we have a vertical asymptote either side. Is x equals 0. So go ahead and do exercise 27 in the book. Pause the video. When you come back, we will continue. Okay, excellent. Let's look at example 5. And example 5 is a trig function, f of x equals tangent of x. And we could, just based on what we know of tangent, say, oh, well, we know that it's got an asymptote, but that's because we already know. What I want to do is I want to rewrite tangent as sine divided by cosine. And now we know that the domain of this function is that cosine of x cannot be equal to 0. Well, when is cosine of x not equal to 0? And we know that that means that x is multiples of pi over 2, but not all multiples of pi over 2, odd multiples of pi over 2. So we'll take the limit as x approaches pi over 2 from below of tangent x, and that's going to be infinite. The limit as x approaches pi over 2 from above of tangent of x is negative infinity. So we have an asymptote at x equals pi over 2, and we can repeat that for every other odd multiple.